Hi everybody, I'm Lorenzo Fontana. Welcome to my session, How are BPF helpers made? The first thing I want to talk about is what's the reason why we need to know how they are made? But, might be because of curiosity, just for fun, but more importantly, to understand how the BPF works and what it does underneath. And also because I asked myself this question while working on something, and I just wanted to avoid to all of you just to do the same thing again. First of all, what are the BPF helpers? Those are kernel-defined functions that can be used to perform specific tasks, right? Accessing data from a map or getting the current process PID, writing to a map, closing a file descriptor, these kind of things. And they are called directly from BPF programs. And they are effectively the only way to interact with the current specific execution context of the program. This is not true anymore some way, because now you can also call kernel function directly with recent kernels, but still this is 99% true. And in my opinion, they are very similar to syscall, and conceptually they are just a way to call kernel functions. So it's just a way of interacting with the kernel like syscalls are. First of all, how do you call a helper, right? The way you have seen it in examples around there might be this, or if you use the CGMBF library, it might be the equivalent in Go, but you just call a function, right? In this case, BPF get current PID TGID, and in this case, you also shift 32 bytes because the process ID stays there and after 32 bytes, but that's not important. Pretty simple. Should be working, right? Not necessarily, because for it to work, you have to either include the BPF helper sage from libbpf if you have it installed, or you just don't have it and you have to declare it yourself. And if you want to declare it yourself, you just open a libbpf header or the VM Linux sage header. You will find something which is, was like, what does it do? You just void pointer to 14. What 14 is, right? You just don't know. You just have a function definition that is just a pointer to function defined as 14. The same call can, if you convert your program to assembly, can be seen there. Just call 14, and R0 is the register where the result is. In this case, I shifted 32 bytes, or in helper with arguments like perf event output, you, before calling 25, which is perf event output, you will also need to pass all the parameters, right? Like the context and the size and everything. But let's go to the juicy thing. How do I implement a helper? It turns out to be very easy. You just define a function using a macro, depending on the number of arguments. BPF calls 0, 1, 2, 3, 4. You can have, and 5, you can have maximum 5 arguments by convention. In this case, is the implementation of BPF get current PID TGID. You implement helpers in kernel, so you have access to kernel structs, like in this case, the task struct of the current process, and you just extract TGID and PID from there. Easy peasy lemon squeezy. Then you have to define a function proto, BPF func proto, for that function, pointing it to the function pointer that you created. You define if the program is GPL only or not. This is very important because you might, while writing BPF program, you might have noticed that you have to pass the license of the program. And sometimes if the program is not GPL, it doesn't work. You might be asking yourself, how do I know when it works? What are the functions that are GPL only versus what not? If you just grab BPF func proc in the kernel, you will have a better idea of that. And then the return type, integer, can be map pointer, other types, void. And then if you have a more complex function, you can also have arguments, right? Arg1, 2, 3, 4, 5, and they can have specific types. You can pass them. But again, where does the number come from? You remember 14, 25 is just a function mapper, which is a macro, For every one of them, it defines the BPF underscore func constant that we've just seen before here. Here, BPF func perf event output. And for every one of them, it also defines the number, right? So if when that macro is expanded, it went to 14, but there are many more, every helper will have its number. So the kernel will know what to call when you call it. Important notes about what I said: helpers can be implemented anywhere in a kernel tree. They can't be added via out of kernel module code because there's just not a way of hooking them into, so you cannot write kernel module that you load as M in your kernel with this code. And BPF helpers are actually not the only way of interacting with kernel functions anymore. There's an LWN article about that. Now probably supports some kind of TCP functions for now. And useful resources, I just tried to find patches, a patch in the kernel that just implements an helper. The latest one is from Alexei, is the BPF sysclose helper. The link is there if you want to take a look. It's very easy to follow it and implement another one of your own. The Python script that generates and man 2 BPF helpers is also very useful for understanding how the documentation is generated out of the helper that you wrote. And that's it. Many thanks, as always, for listening to my ramblings. See you around. Bye-bye. Enjoy the conference.